Okay, welcome to the second part of the Tumblr video. We're talking about the multiplicative trend model. So we're going to take the level and we are going to take our slope and we're going to raise it to some power k, which will give us a forecast into the future. When we dampen that trend, we're going to see that while it's exponentially growing for a period of time, it's eventually going to plateau. It's going to decrease in its slope and eventually flatten off to a plateau. And if you think there's some limits to growth in some kind of process you're trying to forecast going forward, a damped multiplicative trend, which is going to reflect a period of exponential growth for a time that will eventually slow and then flatten out. So let's take a look at what predictions these models make. And we'll take a look at the visualizations in particular that come from these models. So what are we doing now with the models? So up here in these cells we've fit these models with the ETS function, and they now have these variable names. And we're going to pop these variable names into another function in the forecast package. The forecast package happens to have a function called forecast in it, and we're going to use that function to forecast using these three models 115 periods ahead. So this k that's in the book here for when you're at time t, so we're at month 38 and you want to go 115 periods forward, that's the k here. In R, in the forecast package, that variable is called h. That's the steps ahead you want to forecast. The other bit you get to choose here in the forecast package is these levels, and what these tell you are the confidence intervals or the prediction intervals that you'd like to see visually depicted when you plot your forecast. So we're going to see the 20% prediction interval, the 40, the 60, and the 80% prediction interval. Okay, so 115 steps ahead, that's 115 months into the future, about 10 years. And then we're going to look at these four cones for each of these three model forecasts. So we're running that. That takes a little bit more time, but quick nonetheless. And now we are going to take a look at these three plots. And here are the three plots. And this is the additive error, additive trend. This is multiplicative error, multiplicative trend. And here is the multiplicative error, multiplicative dampened trend, no seasonality. None of these have seasonality. And you can see the forecasts that they're making are very different. We've got going up for a long time linearly over the next 10 years and very narrow bands in terms of prediction intervals. And then over here we've got some exponential growth, but because this model, let's go ahead and add another cell. I'm going to copy this, add a cell, and we're going to just print this to the screen. You can see that the beta, which is the smoothing parameter in this multiplicative model, is quite low. But sorry, I should say it's quite high rather. If this were down near zero, this would mean that we wouldn't react to recent changes in the time series when trying to estimate what our slope is. But because this is fairly far away from zero, it's putting about 20% weight on what's happening more recently, and we're getting updates on our slope. And because this is starting to, at least recently, not have the same kind of growth as it had in the beginning. It's a very steep slope here, and because of a downturn here and a little downturn here, the overall slope here that's being estimated is not quite as steep as what's here. And that's translating into where we're coming off here, a multiplicative trend that isn't quite as steep as this additive trend. This additive trend model, if we would also take a look at it, let me add a cell here and print out what this model says, AA, and we're going to press play. We'll see that The beta here is about it. This is 0.0001. This is very near zero. That means we have a trend that is not being updated very much with the recent points. It's a global trend. It's a trend that's estimated by looking at and weighting equally all 38 points here. And we see that that's going to be quite a bit steeper than the estimate that puts a fair amount of weight on what happened more recently here with these downturns. And then over here you'll notice that the multiplicative trend, if we would allow it to dampen, it's going to go up for a while and then turn and flatten, eventually going to some point that looks like about 220 million people in terms of traffic. If you want to get out the upper and lower, the edges of these prediction intervals, you can run this next line, and here you see these intervals. So the 20% the 20% prediction interval has 40% probability below the bottom end. So below this bottom end here, this is the 20% prediction interval, are these values, and below the 70%, excuse me, the 40% prediction interval is this 30% probability, which is this 134, and so on down to this bottom set that goes with the 80% prediction interval. There's 10% below this line, and there's 10% above this line, which makes this outside cone the 80% prediction interval. So that's in the first month 129, then 125, then 122, going all the way down to some value here, and it's getting quite low. It's going all the way down to zero, essentially. So that is what you can get out of the upper and the lower. And then finally, if you want to write this to a CSV, you write CSV, and what you're binding up is each of the three models, predictions, and you're doing $mean, which gives you, let's put in another cell here and show those. We'll print those to the screen. We'll just do it for one of the models. We'll do the mean. This is the mean. Print that to the screen. So this is the middle model's means. So all these numbers here, 137 up to 284, will be these numbers that go with this dark blue line that cuts right through the middle of the cone. Okay, so that is written out, and then if you go back to, and I would say now we're ready to go ahead and stop this session. And we don't want to discard this, because that will, all this work we've done, not that we've done that much, but we have introduced some new lines of code here that print out what the first two models look like. Here's the automatic selection. If we want to save all that, we will stop our session and commit it. Now we're stopping. Okay, file changes have been successfully synced. That's good. The connection failed, which means you're no longer connected. This is a good sign, by the way, to see connection failed. That means you're no longer connected to the virtual machine on AWS. You say OK, you go back to your pinwheel here. In the top, oh, nope, sorry, you close this down. You're back here in the project. You want to make sure that in your files you have your output. So here's your forecast. So it got written, that last line when we said write.csv, we wrote out the three predictions. It's here in this CSV. You can see those three predictions are here. If we want to download this file, we can, and then it downloads here into the corner. I'm using a Chrome browser, and I'm opening this up in Excel, and now I've got my three models predictions, or at least the centers of those cones out 115 months, and I can just take one of these or try them one at a time in my valuation model as forecasts of people worldwide in terms of Tumblr traffic going forward. So I'm going to close that, and I'm going to do one final check. I'm going to get out of all of this, and I'm just going to see that this run has been stopped. So this says stopped. That's this little square box. That means I'm not running any virtual machines now, and I'm not going to be racking up extra charges for Darden, and that is a good thing. And thank you very much.